Welcome back, Geometry Scholars. Today's lesson is a continuation of proving lines are parallel. We talked about parallel lines last lesson, and today we're actually going to work with proving that they're parallel. The essential question is, how can congruency be determined for triangles, and if so, what properties about them can be concluded? And after today's lesson, you should be able to prove that lines are parallel, and we'll be well on our way in that direction. Okay, don't forget on the left-hand side, you can write any questions that you have regarding our notes. And so that way, if you need to ask me something during homework check time, you have your notes right there so you don't forget what you've asked me. So example 1, we're going to complete the proof of the converse of the alternate exterior angles theorem. So we're basically simply completing this proof. As you can see, there are 4 statements. They're on the left-hand side under statements, and there are 4 reasons on the right-hand side. Each statement must have a reason. The first thing they tell us, line 1 is almost always whatever they gave us. So angle 3 is congruent to angle 7, and that's the given. We never have to wonder our reason for that. It's always the given. So angle 3 is congruent to angle 7, and I'm going to go ahead and mark those with my congruency marks to show that they're congruent. And then it says that angle 2 is congruent to angle 3. Well, here's angle 3. And it says that angle 2 is congruent to angle 3. So again, just the one congruency mark. And how do I know that they're congruent? Well, if you look back in your notes from 4.1 and 4.2.43, what kind of angles are angles 2 and 3? They are vertical angles. So they are congruent according to the vertical angles theorem. And as you can see, I'm writing like with shortcuts, and that's fine as long as I can tell what it is. So vertical, V-E-R-T, and then angles. I drew the little angle measurement sign, and then the S, so angles, theorem. And then it says that angle 2 is congruent to angle 7. Well, we can tell by looking at our picture that they are indeed, because 3 was congruent to 7 with the 1 angle congruency mark, and 2 is congruent to 3. So now I can say that 2 is also congruent to 7. And that's all the way back to lesson 1.4 on the transitive property. We're going to call it transitive prop of equality. And again, you can abbreviate if you'd like to. Transitive property of equality is the full term, if you want to write it out completely so you know what it is, but transitive property of equality. So because 2 is congruent to 7, we can now prove that P is parallel to R. Okay, that sign right here means parallel. And our reason for that is the converse of the alternate, and I'm going to abbreviate it, exterior, abbreviate it, angles theorem. And again, if you need to write out all the word, the whole entire word, feel free to, but I'm abbreviating it. So as a review with proofs, the first statement is almost always what they've given us, and therefore the first reason is the word given. And then the last statement is going to be what we're trying to prove, so we never have to really wonder what our last statement will be, but we have to be able to give the reason for it, okay? And so our notes in 2.3 talked about what the converse of the alternate exterior angles theorem was. So if you need to pause this video and look back to read it, you can. The converse of the alternate interior angles theorem basically says that if the alternate exterior angles 2 and 7 are an example, if they are congruent, then the lines are parallel. So since 2 is congruent to 7, P is parallel to R. That's according to the converse of the alternate exterior angles theorem. Going to go on to example 2. Use given angle relationships to decide whether the lines are parallel. Explain your reasoning. So if they told us that angle 3 is congruent to angle 5, is knowing that enough to say that line, actually let me write it as line L is congruent to line M? Is that enough? And if you look back at your notes from the last lesson, yes, it's enough. And I know it's enough according to the converse of the alternate interior angles theorem. So if you do not have your notes out from last lesson, I would highly suggest having them out, because the converse of the alternate interior angles theorem states that if we have a pair of alternate interior angles that are congruent, then their lines are parallel. And so the answer would be yes. Okay? The next question says, if 3 and 6, so 3 and 6, it says they add up to 180 degrees. And it says, the question says, is that enough to determine if the lines are parallel? And again, looking back at your notes from last class, yes, again, it is enough, and it's enough according to the converse of the same side. Let me write converse, same side, interior, again, INT, interior, angles, postulate. Okay? And the converse of the interior angles postulate, a converse of the same side, interior angles postulate states that if two angles that are on the same side in the interior are supplementary, meaning they add up to 180, then the lines are parallel. The last question, letter C, says, what about if 2 is congruent to 7? So I know 2 and I have 7. If they're congruent, does that prove that the lines are parallel? So is there any special relationship between 2 and 7? No, there's not. They're not corresponding. They're not alternate exterior. They're not vertical. So these angles being congruent cannot help me prove anything. Moving on to example 3, we're going to complete the proof. And actually, I'm sorry, there was a mistake here. It should be complete the proof of the alternate interior angles theorem. Okay? If we were proving the converse, we'd be proving that the lines are parallel. Just like we did with example 1, we were proving the converse, and so herefore I was proving that the lines are parallel. But actually here, I'm just proving that I'm completing a proof of the alternate interior angles theorem. So I'm not actually proving lines are parallel because I already know the lines are parallel. Okay? I'm sorry about that, guys. I didn't catch it till I had already given you your notes. And I left it in the Smartboard presentation so I could show you to cross it out. So first up, A is parallel to B. And again, that's the given. We should be pretty comfortable with that step. And then it says that angle 1 is congruent to angle 5. Any ideas why angle 1 is congruent to angle 5? Corresponding angles theorem. And again, you can see that I'm abbreviating, and feel free to abbreviate. And then it also tells us that angle 3 is congruent to angle 1. This one should be very, very familiar. We've done this now for 3 days. Vertical angles theorem. I know it seems like a lot, but there's just some basic theorems of postulates that you will definitely need to know to be successful in this class. And then lastly, since 1 is congruent to 5, 1 is congruent to 5, and then 3 is also congruent to 1, I can therefore say that 3 is congruent to 5 as well. And I want you to take a second thinking about what this reason could be. And it is according to the transitive property of equality, just like one of our previous proofs. Move right along to example 4. We're going to complete the paragraph proof. Now this is a different type of proof. They write it in paragraph form. So it's not the statements on one side and the reasons on the other. They've given us that P is parallel to Q, so we know that. They want us to prove that the measure of angle 4 is equal to the measure of angle 8. So by the given statement, P is parallel to Q. We already know that. Angle 4 and angle 6 form a pair of what? So here's angle 4, here's angle 6. What kind of angles are those? They're alternate interior angles. Okay? So using the alternate interior angles theorem, we know that the measure of angle 4 is equal to the measure of angle 6. We learned that in our theorems last lesson. Since they're alternate interior angles, they are equal to each other. Their measures are equal to each other. Okay? 6 and 8 form a pair of vertical angles. So using the vertical angles theorem, we also know that 6, the measure of angle 6, is equal to the measure of angle 8. And And then using the what kind of property, we can substitute what for 6. Now, our last proof, we used a transitive property. If transitive property as a review is if A equals B, and then B equals C, then A also equals C. So here we know that 4 is equal to 6, and 6 is equal to 8. So we're trying to prove that 4 is also equal to 8. So you could write the transitive property here, but they specifically put in the word substitute. So you can also use the substitution property. So either one would work here. Since they use the word substitute, I'm going to use the substitution property. So using the substitution property of equality, and the measure of angle 4 equals the measure of angle 6, I'm going to substitute measure of angle 8 for the measure of angle 6. So instead of measure of angle 6, I now have the measure of angle 8 in there. So the result is therefore that the measure of angle 4 is equal to the measure of angle 8. Okay? I substituted the measure of angle 8 in for the measure of angle 6 because I already knew this. And since measure of angle 6 and measure of angle 8 are equal to each other, I can substitute measure of angle 8 in, and therefore I'm able to prove my statement. Okay? Again, I know this is a vocabulary heavy lesson like some of our previous ones. We will continue to do proofs, but you have to try to think through what makes sense. This is very logical if you think about what makes sense. Okay, lastly, you do need your compass for this, and so please forgive me as I'm working through this. As you guys know, doing things on the smartboard is not always the easiest thing when it comes to compasses, but you do need your compass for this. If you do not have a compass, you have all weekend to go out and get one. You need to have a compass. You need to have a compass, and if you don't have a compass, do your best to do this, but I want to see angle measurement. I want to see angles and lines on here. So the first thing we have to do is draw a line L, and we're trying to construct parallel lines. So this is to draw a line L and point P not on L. So we already have our line, okay? And here's point P, and point P is not on L. If it was on L, it'd literally be on L, just like that, line L, but it's not. Okay, so that's step 1. And this is choose 2 points on L and label them Q and R. That means you get to put 2 points on the line wherever you'd like and label them Q and R. Go ahead and take a moment to do that. And at any point, if you need to pause the video and copy me and copy what I'm doing, please do. The next step says to use a straight edge to connect, to draw PQ. So I've got to connect P and Q. Okay, so I connected PQ. And then it says step 3. So this is the easy part. Put 2 lines on the line and then connect the point to Q, to your first point, okay? The next step says to use a compass to draw PQR at point P to construct line M. So we have to copy angle PQR. So our first step for copying an angle is, and again, I'm copying angle PQR, so I'm putting the tip of my compass on Q. Okay, there's my point. I'm putting my tip of my compass on Q, and I am going to, I actually just moved my line, so let me move my line really quickly. Sorry about that. Put my tip of my compass on Q, and I need to bring it in. And draw my arc. And don't forget, draw a nice long arc. Okay? And once you've done that, move your same compass up to P. Don't stretch it out. And draw again your nice long arc. And remember, I like to draw a nice long arc so I never have to worry about it again. Okay? Once you've done that, you have to move your compass down. And you have to measure. Where's my? You have to measure how wide it is from the point and I'm almost there. Here we go. Okay, so I had to measure how wide it is from where the arc crossed PQ to where the arc crossed QR. And so now that you've done that, you take that same thing. So that's how wide it is right here, from this point to that point. And so what I need to do is I need to measure how wide it is from this arc to this point. But as you can see, I don't need to draw an arc right here. I need this to be my point, right where my where my marker is, and I need this to be where my actual arc goes, so I can draw a line. So I'm going to turn them around, flip my compass around, and put my compass right there. And again, this width is the same width as it was from line to line. So now that I've done that, I can draw my arc. Okay. Move this little sucker out of the way. Draw my arc. And now you can see I have a point. Oops. Sorry about that. I have a point here where the arc intersected. And I have a point here. Okay. And with those points, when I connect them with my ruler, which I'm just going to draw for you nice and hopefully straight right here, I have parallel lines. And I know I just went kind of slanted to the left-hand side, but you guys get the point. I have literally, no pun intended. Okay. I have parallel lines. So here was line L, and I just drew line, I'll call it line T. I just drew line T parallel. Okay? And I know there was a lot of steps. We basically made an angle. See right here? We made an angle here, here, and here. We copied an angle down, and by copying that angle and extending the line, we made a parallel line. Okay? So normally I would have you guys do the next example on your own, but I'm going to do it with you again because it is tricky. And this one is upside down, which makes it a little bit harder. But first of all, you draw a line out and you draw a point, which you already have. Your next step is to make 2 points on the line. So again, I'm going to make Q and R. And I suggest that you name them the same points I do, so that way it makes more sense as we're talking through this. What is our next step after naming them Q and R? Hopefully you said we need to connect PQ. And I'm going to do connect PQ in green. And there we are. And here's my ray, PQ. Okay. So after I've connected PQ, I now need to make an arc that crosses this ray and this line. So from point Q, I have to make an arc that crosses both of those. So I'm going to take my compass, and I'm going to squeeze it in a little bit. I don't want it too wide. Squeeze it in, and let's use red. Okay, so here's my arc, and I'm going to make it. It's going to cross here. Oh. No, it's not. Erase that. Sorry about that, guys. Okay. Okay, so now I'm going to cross all the way. There we go. So, see, there's the arc that crosses both the line and this ray. Go ahead and do that same thing. What's the next step? After you've done that, move it down to P. The same point, just write down the thing, and make your nice long arc as well. Okay. Our last step, or not, I should say our last step, our next step is to measure how wide it is. And we have to measure how wide it is, again, from this point, which I will notate in red. Measure how wide it is from this point to this point, from where the arc crosses the line and from where the arc crosses that ray. So we have to measure how wide it is. We're going to measure that with our compass. So put your compass on one point. If you need to draw points there, feel free to. You draw them right where that arc intersects. Okay, stretching it out a little bit more. Right there. See how I measured how wide it was? Now that I measured how wide it was, I'll bring this down, and notice I measured it from this point, okay? I'm going to bring it down to, and if you need it again, also draw a point right here, you can, okay? The corresponding point. We've been talking a lot about corresponding and corresponding angle, so this was the corresponding point right here between PQ. I'm bringing it down here, and draw your arc. Okay? And right where your arc is, you now have, right where your new arc is, where it intersects the other arc, you have a new point. And if I take my ruler and connect them, you'll have a nice straight line. Okay? And there's my somewhat straight line, to the best I could, but you can see that I was able to construct a parallel line by using, by copying the angle down. Okay, I kind of created an angle, and I was able to copy down, and I created my own parallel line. So I know that was kind of tricky because we were upside down, but again, basically the steps are, I named 2 points, and if you want to write this down in your notes or in your summary, I named 2 points on the line, okay? I drew an arc at Q, and then I drew the same arc at P, okay? So I drew the blue arcs that you see on the paper, okay? Then I measured Q's arc. I measured how wide it was, and once I measured how wide it was, I used the measurement to draw another arc above P. Okay, so that's where I used the measurement to draw an arc above P, which was the red one. And then where that intersection was is my second point, and I was able to draw my straight line to the 2 points, because any 2 points make a straight line. Again, construction's hard. I know it's difficult not seeing it in person. But actually, honestly, the smartboard is probably almost a little easier with seeing the compass, because you can actually see the compass versus trying to figure out what my hands are doing on the dot cam. But we will do constructions in class, but what we are doing here is just we are constructing parallel lines, okay? Constructing parallel lines. We'll have the opportunity to do it in class if it's on the test. And it's important for you to see tools like this on the smartboard, because when you take the FSA, you're going to have tools like this on the smartboard as well. Okay, to wrap it up, a summary of what we learned. As a recap, we've been talking about proving lines are parallel, so we completed multiple proofs using parallel lines and proving that they're parallel. We used the converse, which means the opposite of the alternate exterior angles theorem. We said whether or not lines could be proved parallel. We proved something using the alternate interior angles theorem. We completed a paragraph proof. And we made angle constructions. We made parallel line constructions. Okay? Have a great day, guys. See you next class.